One of the many great features of Katana is its ability to load incredibly complex scenes at near instantaneous speeds. It does this through the deferred load process. A great analogy for this is to think of how a harbor works. Ships are waiting to use cranes to offload their containers. We can think of the ships as the data caches or files on disk, and the containers as their data. This is how legacy DCCs work. All of the ships/caches need to be offloaded before the user can start to access a single piece of data. This can be a very long process, as there may be hundreds, if not thousands, of ships waiting to offload their cargo. Katana takes a slightly different approach to allowing users to access their data through a process that we call deferred loading. Katana does not offload any containers when the application starts, only the manifest, or a lightweight file that shows where the data is stored in the harbor. This way, whenever the user wants to modify a piece of data, Katana can look at which ship/container the data is on and load just that container. This allows Katana to load at near instantaneous speeds, as the user will not have to wait for all of the containers to be offloaded on startup, but rather on demand. We can see this process in action if we go over to a blank Katana scene. From there, we'll want to open our file for the loft asset. The first thing we'll want to note is the size of this file, which is a mere 314 kilobytes. Since this is just the manifest we're loading in now, these 314 kilobytes will allow us to access gigabytes of information. These manifests are represented in Katana with nodes. Each node has specific information on it about what it does, such as where it will attempt to retrieve data from, or how it may modify existing data. One great example of this is the Alembic in node. If we look at the parameters here, we can see that we have a parameter called ABC asset, which is a path on disk to a geometry cache. If the node is our manifest, then this parameter ABC asset is going to be an entry in our manifest of where the data is located. If we jump over to this location on disk, we can see that this node is referencing our loft geometry, which is not a lightweight file at about 100 megabytes. Now that we've seen how the manifest relates from our analogy, let's take a look at how we can start to use the manifest to load data into our scene. We can do this by heading over to the scene graph. We'll go ahead and put our scene graph and our viewer side by side so that we can get a better view of what's going on. As we can see, there is nothing currently visible inside of our viewer. This is because we have not asked our manifest for any information. To ask our manifest for information, all we need to do is start expanding our scene graph. As we start to expand locations, we can see that different parts of the loft cache load into our scene depending on where we've expanded to.